Okay, so today we move on to our second last chapter in engineering mechanics, which we are now currently exploring, which falls under dynamics. So the topic that we're learning today is something called kinematics, but on a rigid body. Previously, we have learned kinematics, but on a particle. Everything is a particle. You've got things like S, V, A, displacement, velocity, acceleration, but on a small particle. So now we are studying on a rigid body, something or some object with a size. So basically, when you are looking at motion, for example, for any particular body, you can categorize them into four types. So you've got something called rectilinear translation. So rectilinear translation is a direct and linear translation. Linear, straight line. So it can be in any direction, but it's a straight line translation. So you just move from location A to location A prime. This is a direct and rectilinear translation. So this one is very simple. Next, there will be something called curvilinear translation. It moves, but it curves. So if you look at this object, this link is actually rotating at a fixed axis, but this parallel link swinging plate is actually curving. So this is called a rectilinear translation. We're not looking at this thing, no, not this one. We're looking at this blocky object. So this is a curvilinear translation. Next, there is something called fixed axis rotation. So this link is something called fixed axis rotation. This one, fixed axis rotation. So rectilinear, curvilinear, fixed axis rotation. This one, something rotating, things like a clock, motor. And finally, you have something called general plane motion. So general plane motion is basically you combine two things, linear translation and also curvilinear translation, which means you have you're doing two things. If you're looking at this is a rotation at a fixed axis. This piston is actually rectilinear translation. The one which is rotating and translating is this connecting rod. So this connecting rod is actually translating while rotating. So it's doing two things. So if you look here, these are a combination of all the motion lah. You've got this one, this is a piston. This piston just travel back and forth, back and forth. This one, this is actually rotating at a fixed axis. This one is behaving some sort of like a curvilinear translation, and this one is undergoing general plane motion. So it rotates and also translates. So among all four, this is the hardest to analyze. Number 4 is the hardest to analyze. You can do simple calculations, but for extended period of time, you need to use a computer in order to solve all the vectors correctly. So there are a few important formulas in kinematics of rigid body. So a lot of the things that we are learning in this chapter is on this part. We'll be learning a lot on fixed axis rotation, this one. So these are some of the formulas which is very important for you guys to remember. And all these things, we need to derive it, I guess. Let's derive it. So we have got two things, I suppose. How do I do this? Something like this. So previously you have learned on linear. Now you guys are learning something called angular. So linear motion, you've got S, which is displacement. What do we call this one? Displacement. Okay. The unit is probably in meter. Now for angular, you have theta. It's called angular displacement. So the unit now is no longer meter lah. The unit is angular, rotating angular. So you can either use radian or degrees. Radian or degrees lah. But most of the time we are going to be using radian lah. So the unit is radian. So you have velocity. Okay, so velocity. The unit is meter per second. So now you have something called omega. Angular velocity. So it is a radian per second. This is the unit for angular velocity. After that, moving forward, you have acceleration. Let's write it down. Acceleration. Meter per second squared. Or meter per second every second, right? Either way. This one will be alpha or angular acceleration. So radian per second squared. So these are the three things lah. Three main things. So if you have things like when your motion is undergoing constant acceleration. I gotta stop this one first. So for displacement, you know already lah what to do. These are pretty much very clear. So for angular displacement, I'm going to explain angular displacement better. So theta is angle. What is an angle? So let's say you are doing, so this is a circle, this is the center. Let's say this one. Let's say it is, what kind of angle are we looking at? Let's say this one is 30 degrees. It looks more than 30 degrees, looks more like, yeah, let's say this is 60 degrees. So 60 degrees, you can represent theta is equal to 60 degrees. 60 degrees, okay? So you can represent theta also in terms of radian. Theta is how many radian. So you have to be very good in radian lah. So radian, you have to remember this. Pi is equal to 180 degrees. So pi, what is pi? 3.142 is equal to 180 degrees. So if you have 60 degrees, what is the radian? How much is the radian? So this is the thing that you have to remember. Pi is 180. So you just have to use this conversion. Pi is equal to 180 degrees. X is equal to 60 degrees. It's either pi or 3.142. So just use this conversion. So what you do next, you can cross multiply. Okay, cross multiply. So it becomes 60 times 3.142 equals 180x. So now x becomes, what do you get now? Punch in your calculator. Although you are looking at me punching my calculator, use your calculator. 60 times 3.142 divided by 180. So you're gonna get 1.05 radian. So this is the radian. 60 degrees is actually 1.05 radian. Yeah, definitely we need to do more. Let's do more. Are you okay with this? So yeah, you can try out using on other angles lah. So angular velocity, radian per second. So let's check out angular velocity, omega. Let's do some calculation on omega. So omega is equivalent to theta over time. Just as linearly you learn V is equal to S over time, right? So it's the same thing. Or something more accurate would be theta minus theta naught over time. S minus S naught over time. So this is more accurate, right? From this equation, from this one, you get V is equal to V naught plus AT. Am I right? Correct. V S minus S over time. Can also V minus V naught. This looks, this one is acceleration already, so wrong. S minus S naught over time. So this one is okay. So this one is for velocity. This one is velocity. This is one also the same velocity. Okay, theta, everybody understand everything? Theta, what else is there? Plenty lah. We have learned about radian. We have not yet learned something else. Sometimes, so theta, you can represent them in this one degrees. Sometimes theta, you can represent them in radian. Sometimes theta, you can represent them in things like I think pretty much that's it degrees or radian. Cycles also can cycles. So if you get what is 100 cycles or 100 rotation? So 100 rotation is equal to, because one rotation 360 degrees is actually equal to 2 pi radian. So if 100 cycles, 100 times 2 pi. So you're going to get 200 pi 200 pi radian. Okay. 100 rotation, similar thing. Same thing. Let's explore again. Angular displacement. I think that's it lah. Cycles also people say, rotation also people say. So this one is okay. Next, what else? Next we gotta look at, I think this one we have learned a lot. We've done a lot of exercise in previous chapters, remember? Kinematics of particles. All are on linear motion. This one we've done a lot. Theta. Theta we've done some exposure lah. Things like degrees, radian, and also rotation or cycles. So you guys are okay with this. Next, the thing which is important for us to learn is something called omega. So let's do omega now. So omega, if you are converting linear, you're going to have V, right? V. You're going to get something called meter per second. This is something called velocity. This is for linear. So when you're doing angular, you have something called omega. So this one will be in radian per second. So this one is angular. So what else is there? So let's say something is rotating. What is rotating? Let's say it makes 270 degrees in 5 seconds. So let's say the displacement is theta is equal to 270 degrees in 5 seconds. Something rotating. Let's see, maybe from here until here. It rotates 270 degrees in 5 seconds. Let's convert them into omega. So omega is equal to theta minus theta naught divided by time. So this is omega. So now you need to convert lah, 270 degrees in radian. So how you can remember this one lah. Pi is 180 degrees. X is equal to 270 degrees. And now you cross multiply. You get 180x equals 270 times 3.142. X is equal to 4.71 radian. So you get 4.71 2 minus original 0 over time. Time is 5 seconds. So what do you get? Bahagi 5. You're gonna get 0.942 radian per second. Omega. So this is omega. Okay. Everything clear? What else can we do? Sometimes omega, you're gonna see things like omega. Sometimes they want it in RPM. They want the angular speed in rotations per minute. So, can you convert this one into RPM? So typically things like motors, a lot of things you can really visualize the speed. Visualize the speed in RPM. If somebody say this motor is rotating at 0.942 radian per second, nobody understands. Nobody cannot visualize anything. So people will stick with this one. How many rotation per minute? So in order to convert this, you need to use a formula, or you just have to remember. So omega is equal to 0.942 radian per second. So change second to minute. So if you want to cancel off second, right, so second gotta be here lah. Minute has to be here. So 1 minute is equivalent to 60 seconds. Betul ya? So 60 second bahagi 1 minute, what do you get? 60 second divide by 1 minute. What do you get? 60 second per minute. Something's not right, right? 60 second per minute. Correct lah. 60 second over 1 minute. This one is actually equals to 1. Because there is 60 second 1 minute. So top equals bottom. When we divide them, becomes 1 minute lah. So this one becomes 1 minute actually. So now that you have S at the bottom, this one at the top, so you can cancel off. What you do is, this one can be cancel off the unit. So now your equation becomes 0.942 radian kali 0.942 times 60. So now you have 56.5 watt radian per minute. But this is not RPM yet. You need to change to to rotation. So you gotta do the changing again. You have to do the translating again. So now let's do it. 56.5 radian per minute. I need to get rid of radian, so I gotta put radian at the bottom. 1 radian is equal to who would know? Rotation. 1 rotation is equal to 2 pi radian. This one can do lah. 1 rotation is actually 2 pi radian. So now this one radian can be cancelled off. So you're gonna get 56.5 bahagi 2 bahagi pi 9 rotation. So this one can be cancelled off. Rotation per minute, or equals 9 RPM. Is it confusing already? So this is how you convert radian to RPM. We gotta do another one. Definitely I need to add one more page. Keep insert new slide blank. So just now we were doing omega convert to RPM. How about the other way around? RPM convert to omega in radian per second. Let's say I have something like 100 RPM convert to radian per second. Can you do this? Obviously 100 rotation per minute. So let's write down properly. 100 rotation per minute. Again, you need to eliminate the minute, right? Minute is at the bottom. You gotta put minute here lah. Baru boleh cancel. You want to convert to second, so you gotta put second at below lah. What do you multiply that does not change original value? You need to multiply by 1. So 1 minute is equivalent to 60 seconds. This one does not change the value, because in every 1 minute there is 60 seconds, so this becomes 1. Next, you need to change rotation. So rotation is at the top, you gotta put rotation at the bottom. So rotation, 1 rotation is equal to 2 pi radian. Again. Let's see, can we cancel this off? Rotation can be cancelled off, done. Minute can be cancelled off, minute. So now you're gonna get, multiply them off. Multiply them off, 100 times 2 times pi divided by 60. 10.47, is this correct? 10.47 radian per second. So this is the conversion. Right, 20.94. Let me calculate again. 2 times pi times 100 divided by 60. 10.47, correct lah. So if you look at this formula here, you can use this formula lah. Omega is equivalent to 2 pi n over 60. 2 pi n over 60. 2 pi n over 60. So this is a very important formula for you to remember. If you don't remember, you have to derive it again lah. Omega is equal to 2 pi n over 60. What does n stand for? N stands for RPM. 2 pi n over 60. What else? So this one okay. Angular velocity, I guess pretty much lah. This one is okay. Next will be this one, angular acceleration. I gotta add more slides again. Keep adding more slides. Where do I add here? Home. New slides, blank. So now let's look at acceleration. So if it's linear straight line, it is meter per second squared. Now you have something called angular acceleration. So kalau linear is actually difference in velocity, right? V minus V original over time. This is your A, or your acceleration. So when you're looking at angular acceleration, it's no longer this lah, but it is almost similar. Omega minus omega naught divided by time is equal to alpha. This is what happens when you are looking at angular acceleration. So previous unit used to be meter per second squared. Current unit will be, for angular, radian per second squared. What else is there to teach? This one, angular acceleration, I guess. Yeah. And then one final thing. Do you still remember? When you have any motion under constant, where is important? I gotta take this one. Okay, here is good. Constant acceleration. You still remember? For linear motion, linear. Let's take out linear. Now you have angular. Linear motion kita ada 3 formula kan? Formula 1, Formula 2, Formula 3. V is equal to V naught plus AT. This is for linear. Angular, just convert. Omega is equal omega naught plus alpha T. Same thing. Second formula. S is equal to plus V naught T plus half A T squared. Same thing for here. S now you got to change. Theta naught plus omega naught T plus half alpha T squared. Looks complicated a bit, but you get the hang of it. Final formula, V squared is equal to V naught squared plus 2A S minus S naught. This one's gonna be omega squared is equal to omega naught squared plus 2 alpha now. Theta minus theta naught. You've got so many formulas. So which one is very important? I guess all the rectangle ones. Let's write down. This one is important already. And you guys know already this is important. This one is important. This one is important. Now when we are analyzing angular motion, similar behavior. Ini okay tak? Omega minus omega naught. Ya lah, this one is important. Ini okay je kan? This one you know already lah. Let's go up. Yeah, this one is crazy important lah. What else? What else is important? All the rectangular ones are important lah. And all this important formula, you can find out it from here. This one, have we covered? This one, have we covered? Not yet. This one. Okay, this one we have covered. Done. This one we have covered. Done. This one also done. This one not yet covered. So the behavior is almost the same lah. ds over dt is equal to v. So now d theta over dt is equal to omega. Gotta put a new page lah for this one. Keep. I gotta put a new page here. Insert new slide blank. Okay, let's move on. There's much to understand, huh? Linear. When you learn linear, you have things like this lah. ds over dt is equal to v. So when you go to angular, you're going to have d theta over d time is equal to omega. What else? dv over dt is equal to a. Now d omega over dt is equal to alpha. Yeah, that's the thing lah. Similar thing. Last time we have v dv is equal to a ds. Now we have omega d omega is equal to alpha d theta. Similar thing. So no need to worry on formulas. Formulas will be given to you if you forget. But most of the time, if you are doing exercises, you will remember all these formulas on your own. And is all this formula useful? Yeah, pretty much. Not only in this subject, in a lot of other subjects. Later on, you'll move on to powertrains. You'll move on to machine designs. You need to calculate all this. Okay. So this one is covered. Done. Relationships. Okay. Now we gotta learn about something called relationships. Add one more slide. Where do I put this one? Here, probably here. New slide blank. We're gonna learn about something called relationship. What kind of relationship? Linear to angular. There's no n here. Angular relationship. Man, I'm bad at writing. Okay, what is the difference between linear and angular relationship? Let's look at something rotating. What will it be? Let's say you have a pulley. Pulley is here. Pulley is actually rotating at a fixed joint here. So let's say you what is this rotating at? No. We gotta start something more basic. Let's say I have a circle. This is my perfect circle. This circle has a radius r. Okay. Radius is r. What is the circumference? Circumference of this circle. Anybody remember? I know you remember one thing, Area is equal to pi r squared. This one remember lah, definitely. Or area is equal to pi d squared over 4. This one is also something very important for you to remember. But this one is area, right? Seldom we use circumference. Circumference ni benda. What is a circumference? Circumference is this distance. In Malay, we call this ukur lilit. Yeah, in Malay we call that. So in English we call it circumference. So what is the circumference? Circumference of a circle is equal to, I don't even know what circumference what L C give it a name C good. Circumference is equal to 2 pi r. 2 pi r. Circumference is this one So circumference is 2 pi r. So from this formula, basically, you can get theta. Theta at circumference is actually theta, right? Am I right? But in angular form, angular format. So theta is actually the distance 2 pi r is circumference let's give it another name. S. Yeah, it's actually displacement. Circumference is linear displacement. Okay, so this is the one S is circumference and it's equal to 2 pi r. How do you get this formula? It's actually like this S is equal to r theta. This is the formula to get displacement from any angle. So this one is actually making 360 degrees. So you know already pi is actually cannot make a proper pi pi is actually 180 degrees. 2 pi is actually 360 degrees. If this one is 360 degrees, the circumference S is equal to r kali, now the theta becomes 2 pi. S is equal to 2 pi r. So this was the formula that we have been memorizing for so long. I think circumference you will learn in standard 3 code. Standard 3. 10 years ago or 20 years ago. So S is equal to 2 pi r. So let's say if I want to get the circumference for this angle, this one. Let's say I want to get for 135 degrees. At 135 degrees, what is my displacement? This one. What is this? So S at 135 degrees can I say like this is equal to r theta. Now you gotta change cari x is equivalent to 135 multiply this one and this one. 180x equivalent to 135 pi. X is equal to how many radian? 135 divided by 180, 2.35. Okay lah, 2.35. Hopefully correct, 135 pi divided by 180. 2.36 actually. 2.36 radian. Okay, so plug it in lah. S is equal to radius. What is the radius? Let's say I'm giving the radius as 10 meter. So 10 multiplied by 2.36 dapat 23.6 meter. So if you haven't noticed yet, radian is actually not a unit. Really not a unit. How do I say this correctly? It's actually a unit lah, but it is radian is dimensionless. Radian is actually dimensionless. How do you get radian? Where do radian come from? Radian comes from ratio. Radian comes from pi. Pi is radian lah. Where do pi come from? The ratio of radius to circumference lah. This one S is equal to r theta. So they make experiment lah. This one very long time ago. S is equal to r theta. They find out the bigger the radius, the bigger the circumference, and the ratio is the same. The ratio is by pi. So this is the thing lah. So pi is dimensionless. You can multiply anything with pi, you get the same dimension. 10 meter multiplied by 2.36, you don't get 23.6 meter radian. No, you just get meter only. Okay. So yeah, we're not even halfway there yet. I gotta add more slides. Keep insert here, insert another blank slide. So now we have established S is equal to r theta. So since we have established S is equal to r theta, you can do this one. ds over dt is equal to radius. Radius tak berubah, theta berubah. Kenapa radius tak berubah? Ini berputar macam ni. It rotates from certain angle to certain angle. Radius remains the same, so radius no change. So this one change to d theta over dt. ds over dt you get already v. R is r, no change. D theta over dt you get omega. So this is another very important formula. V is actually linear. R ni radius lah kan, radius. Omega is actually angular velocity. So this is what I was trying to get to, which is linear velocity is equivalent to radius times the angular velocity. Meaning, what does this mean? So it means if you are traveling, let's throw something huge. Let's throw a circle. How to get a perfect circle? It's impossible. Okay. Let's say you have a circle. What is this? This is a big circle. What kind of circle is this? Let's say at the fun fair. Remember at the fun fair, what do you have here? You've got people dangling all around the fun fair. I don't remember. Merry-go-round. It's not merry-go-round. It's like the London Eye. That thing lah. The fun fair ride thingy. So let's say the radius is huge. The radius. Berapa radius dia? 10 meter boleh lah. 10 meter, 20 meter. Let's say the radius is 15 meter. On this. I know wrong. This is called a Ferris wheel. Right. Let's say you are on a Ferris wheel. So 15 meter. So this Ferris wheel rotates. Let's say it rotates at 10 RPM. 1 minute rotate 10 times. Crazy, right? Too fast, 3 RPM. Never mind lah, 5. Let's say this is super right. So 5 RPM. Ferris wheel, 15 meter, 5 RPM. Where are you? You are here lah. Very happy in this Ferris wheel. This is you. So what are the data that we want? Omega is actually equals 5 RPM. Omega in radian per second. Remember the formula? 2 pi n over 60. So you can convert lah. So you're going to get 2 pi times 5 bahagi 60. Berapa radian per second? 10 pi bahagi 60. 0.52. Boleh lah. 0.52 radian per second. See what I was talking about? Nobody can really imagine 5 RPM people can really imagine. If I tell you, an engineer tell you this is rotating at 0.52 radian per second, nobody can imagine anything. That's why people stick to RPM. It is something that you can visualize. So now, although this guy is rotating, it does experience something called linear velocity. This linear velocity is called tangential velocity. This velocity is tangential. So wherever you are on the right, you experience this one. V, tangential. V, tangential. V, tangential. V, tangential. So you feel the tangential velocity. So it's not linear. Boleh lah linear lah tu. Tangential. You feel the straight line lah. The straight line velocity. And what is your straight line velocity? Use this formula lah. V is equal to R omega. Your radius is 15 meter. Your omega is 0.52. You experience times 15. 7.86. You experience 7.85 meter per second. If you convert this to kilometer per hour, berapa? Kali 3.6 times 3.6. 28.3 kilometer per hour. So that is your tangential velocity. So let's say you are the park owner and you want to increase profit. How do you increase profit from this Ferris wheel? So you add one more level. There's another level here. Boleh lah. Bagi ramai orang duduk. I gotta make a circle first, huh? This is a circle. Another one here. Another one here. Increase profit. But how do they get down, huh? I don't know. So this one, second class. So now the radius here becomes 7.5 meter. So kalau di ujung, dia akan rasa laju. What kind of laju are we talking about? It's 28.3 km per hour lah. Or 7.85. So, first class. Second class, berapa velocity dia? Velocity dia adalah 7. Okay, use this one, right? V is equal to R omega. Radius is 7.5 times 0.52. 0.52 what radian per second. Berapa? 7.5 times 0.52. 3.9 only lah. 3.9 meter per second, which is halves. I think if you convert, you get 14.2 kilometer per hour. So, the further you are from the center, the faster you are traveling. If you are here, you feel half the speed, half the tangential speed. If you are here at the center of the whole thing, you get 0 velocity. So that's the thing lah. So that's the thing. So what else can we do? So many slides open already. File. Go back. Insert new slide. New slide. Blank. Let's do one more. One more. Quiz. Short quiz. So this is planet Earth. Boleh Why? So the circle. Circle is... Okay, this is the circle. This is planet Earth. What is the radius of planet Earth? Use your phone. Radius planet Earth. Radius planet EARTH. Radius Earth polar radius is 6356 km. So radius kita adalah 6356 km. This is the radius of the planet Earth. So you guys are here, right, on top of the air, on top of this planet Earth. So the Earth is rotating. What is the speed of our planet? One rotation in 24 hours. Okay one rotation in 24 hours. Betul lah tu. So find out for me what is this. what is V tangential. Then we are experiencing right now 1 rotation in 24 hours. Boleh ah? 1 rotation in 24 hours. Betul lah tu. And this one I want to know in kilometer per hour. Find out for me. If you can do this, you have not wasted 1 hour of your time lah. You really understood how to do this. Okay, so try this out. Okay.